Good afternoon, all. So, in the previous lecture, we discussed different kinds of statements in C. I'll just quickly glance through that, and we'll move on to today's lecture. So, in the previous lecture, I forgot mentioning about null or empty statements. Basically, if you put just a semicolon, it's a null statement. Usually, every statement should end with a semicolon. After that, whatever number of semicolons you put, it means those many null statements you are giving. Okay. So that is one kind of statement. And then we looked at expression statements. This is what we spent most of our time in the last lecture. So four kinds of expression statements are there: input statements, output statements, pure expressions, and assignment statements. Input statements like scanf you already know, getChar you will know later. Output statement, printf you already know, putChar you will know later. Pure expressions like any arithmetic expression or relational expression or any other operators you use. Just that expression itself is a pure expression. You're not assigning it to anything. You're just writing that statement as such, that expression as such. And then the assignment statement means you're assigning that expression to some variable. Okay, so these four kinds of statements are called expression statements, and only expression statements have values. No other kinds of statements have values. Like if you look later, declaration statements, you declare variables or functions. They don't return any value. You're just declaring them. That's it. If else statements, conditional statements, or selection statements, different names for the same kind. If else is one kind of statements which you already know. Switch is another kind of statement which we'll see later. Iterative statements are looping statements: for loop, while loop, do while. These are different looping statements. And then jump statements, we discussed this last time: break, continue, return, exit. And compound statements. So any sequence of statements, if you put them in curly braces, that is called a block. So that block is called a compound statement. So compound statement is nothing but a sequence of statements where each of the statements in the sequence can belong to any of the above categories. It can be a declaration statement, it can be a loop statement, or it can be iterative statement, whatever it is. Okay. So except expression statements, no other statements return any value. When you declare something, it doesn't return any value. If else statements don't return a value. Loop statements don't return a value. Jump statements don't return a value. Compound statements also don't return a value. Okay. So only expression statements return a value. This we discussed last time. An expression, what is an expression? An expression connects one or more constants or variables with one or more operators, right? This also we discussed last time. And an expression can be part of a statement or it can be a statement itself. Like if you consider this example, x equal to 2 plus 3, this 2 plus 3 itself is an expression. Okay, this can stand on its own. You can just write 2 plus 3 semicolon and leave it there. So the program will not raise any error. It does not say, okay, what are you, you're not using this value anywhere. It may give a warning, but that's not an error per se. Okay, you're not using this value. Why are you writing this? It's of no use, but technically it is correct. It's valid. So pure expression is also an expression statement. And when you assign it to something, that assignment statement is also an expression statement. Okay, usually we use assignment statements. We don't use expressions just like that. All right. So they have values. Pure expression 2 plus 3 has a value, that is 5, obviously. And the overall assignment statement, x equal to 2 plus 3, also has a value. I hope you understand. Not x having a value. The entire statement x equal to 2 plus 3 has a value. Okay. X as a variable will have a value, that is 5. But the overall statement itself has a value, that is also 5. Okay. So whatever is the value of LHS, that will be the value of the entire statement. All right. So that this statement can now become an expression and be part of another statement. Okay. The way 2 plus 3 as an expression is part of this statement, this entire statement can be treated as an expression and be part of another larger statement. And that is possible because the statement as a whole is having a value. If the statement as a whole does not have a value, only if x has a value, then you can only use x in some statement. But you cannot use this entire statement in some other statement, right? You are able to do that because this entire statement also acts as an expression. That is why it's called expression statement. This can be used as part of some other statement. Okay, so that's the idea. And like I said, among all kinds of statements, only expression statements have or return a value. This I just mentioned, no other statements have or return a value. All right. And then we discussed some examples. I will not get into that. We spent quite some time in the last class. I said that, like I said, input statements, output statements are also expression statements. So printf also returns a value, scanf also returns a value. When you say printf hello, hello is not the value of printf statement. Hello is the output of printf statement. the value of printf statement is the number of characters, that is 5. The number of characters that it prints, that is 5. Okay, so the statement which is printed by printf statement, that is the output of printf, not the value of printf. So there are two different things. Okay, so if in the exam, if you are asked just printf hello, what is the value? Don't write hello. That is not the value. Value is 5. Okay, so that's the difference. Similarly, scanf also has a value, that is the number of input values that it scanned successfully. You may give 10 values, but it may scan only 3 values successfully. In between, it may encounter some error or whatever it is. I discussed it elaborately in the last lecture, so I won't get into that. The number of values successfully scanned by scanf statement, that is the value of the scanf statement. That will be returned by scanf statement. Okay, fine. Okay, in the last lecture, I wanted to discuss structure of C program, but I could not discuss. I wrote it here. So let's quickly go through it. So minimal structure of a C program. Any C program should have minimally these two parts: include statements and int main. Okay. Technically speaking, include statement is also not necessary. It will not give any error if you don't involve include statement. You can just write int main. But that is of no use basically, because you cannot take any input, print any output. You cannot do anything. You can do some operations, but they will lie inside the program. There is no interaction with the user because you are not including stdio.h. So you can't use printf and scanf. And if you can't use printf and scanf, that program is as good as useless, right? You're not doing anything. So technically int main is sufficient, but for for any practical use, minimally printf and scanf are necessary, and for that you need to include stdio.h. Okay, so minimally these two blocks are necessary. So hash include stdio.h, first block, and then any other libraries that you include. You can include mat.h, you can include stdbool.h, you can include string.h. We will see some of these libraries later, but minimal basic library which you always need to include is stdio.h. And as you already know, it is standard input output library. It is not studio.h, so don't make that mistake. And printf and scanf, etc. are defined in stdio.h library, so it needs to be included. Fine. Int main, this is the main block where the entire code is written and all the operations happen. And int main is the entry point to the code. Like if you see some of the points to be noted, every statement in C should end with a semicolon. This you already know. If you miss semicolon, it will give an error during compilation. Yeah. I'm about to explain. Yeah. So first, every statement in C should end with a semicolon, that you all know. Okay. And now second point, which is also related to the question he asked, int main is the entry point for a C program. So first, let me explain what do we mean by entry point, and then I'll explain the difference between int main, void main, why we need a return statement, and all those things. So you may have many lines before int main. It doesn't matter. When you compile the program or when you run the code, the system starts from int main line. It looks at the lines inside int main. Okay. Now you may say, okay, then what is the use of writing the lines outside int main? Usually we declare global variables and functions outside int main. And usually they will be referred to inside int main. Okay, like you may use that variable somewhere inside main function, and you may use some user-defined function inside main function. You will understand user-defined functions when we get into the functions topic. So there are two kinds of functions. One is inbuilt functions like printf, scanf, etc. They are inbuilt functions. You directly use them. Other is user-defined functions. Like in the last class, we looked at an example. I just wrote an add function. I take two numbers, I add them, I return the output. So this will be my function. Now, whenever I want to add two numbers, every time I won't write entire expression. I'll just call this function with these numbers. It will give me the value. I can write many kinds of functions like area of rectangle or area of square, which you did in the labs. That can be converted to a function and used inside some other program, right? That entire program can be sort of wrapped inside a function, and this function can be reused by someone else in a larger program. Okay, so user-defined functions are there, inbuilt functions are there. So we can define user-defined functions outside main, and we can call them in main whenever needed. Fine. So whatever is there inside main, only that will be used. If the function is not called, it's defined, but it is not called, then it's of no use. That function just lies there. without any use. Only if it is called inside the main function, then the operating system looks or searches for that function in the entire program. Is it defined elsewhere? Outside main or inside main, is it defined elsewhere? Then it will use the definition and run that function. But the call needs to be happen. The call needs to happen inside main function. Okay. So whatever you write inside main function, that is the main part. And everything outside main function should have a reference inside main function. Otherwise, you will never go there. Okay. So main function is the entry point, and everything else is only supporting this. Fine. And then what is the difference between int main and void main? The way we define functions with all the parameters. Okay, what kind of input a function can take? Will it take an integer or will it take a character? And what kind of output the function will return? Will it return an integer or will it return a character or will it return a float? All these data types are defined. So the data types of the input arguments as well as the data type of the output of the function are defined. You will see that when we look at functions. Main is an inbuilt function. It's a system function. So it is predefined. The basic default output data type of main function is int. So the correct format to specify main function is int main. It expects an integer output. All right. If you write void main, it will just give a warning. It will not give an error. Void main means it is not expecting any output. Void main means you're not giving any output. But by definition, it expects an output. Okay. You can use void main. It will give a warning. It will not give an error. Now, what integer output will you return? Like you would have written written the statement return 0, right? By default, it returns 0. 0 means it executed successfully. No errors. It executed successfully. 1 means there are some errors. Anything other than 0 represents different kinds of errors. Now, you may also have tested, what if I don't give a return statement? It still works. Or what if I give return 1? It still works. So then you may ask, why to give return 0? 1, even if I don't give any return statement, it is working. Second, instead of return 0, if I'm giving return 1 or some other value, even then it is working. Then what is the use of return statement? So the point is, usually during the course, whatever examples or whatever programs we are writing, they are individual standalone programs. That program you're writing, you're running, you're executing, done. But many times this program may be part of a larger pipeline. In the sense, so let me give you an example. Suppose this is a folder and there are 3 files, as you can see. And if I want to list the files, I can say ls. So it is listing the files in this folder. All right. So ls is a command which lists the files in this folder. But suppose I have many files. Maybe I go to the previous. I have some, I don't know, 6, 7, something. Suppose I have 100 files. I want to know the number of files in this folder. All right. I can't keep counting manually. Right. So what I will do, ls will give me the list of files. I will give this list as input to another command, which will count the entries in the list and tell me the number. Okay. So how to do that? ls pipe, this bar is called pipe. So the output of ls command is being piped in to the second command. The second command is wc. Wc basically means word count. So this is telling me 3 values. This is giving me 3 values, 7, 7, 357. Basically word count counts 3 things: the number of words, the number of lines, and the number of characters. Okay, in the input. In this case, there are 7 lines, and in each line there is only 1 word. Each file name is 1 word. So number of lines and number of words are same. But in some other case, if each line has more than 1 word, then the number of lines and number of words will be different. 357 is the total number of characters in the file names, all the characters. Okay. But suppose I don't want number of characters and all these things. I will just say, just give me the number of lines. Okay. It just gave me 7, which means there are 7 files in this folder, files and folders together in this folder. That's all. So what I am doing, I am listing the files using ls command, and that list I am sending as input. So the output of ls is becoming input to some other command, wc -l. Okay. Now, similar thing. Basically, ls is what? Again, it is some executable file. which is created from some program, most probably C program, because most of the system commands are written in C. System programs are written in C. Okay, so some C program is converted to an executable. That executable is named ls. Instead of a.out, it's named ls. So when I am typing ls, some a.out is running. Okay, which means some main function is being called, and this program is giving an output which is redirected to some other program. WC is another program executable. Okay, so the point is, since ls has successfully executed without any errors, its output can be piped to some other program. But suppose ls ends with some errors, okay, then the program crashes, and I don't know why it crashed. Okay, and okay, last two, boy and girl, get out quickly, go outside and play whatever you are doing, go, leave quickly, don't waste my time. So if the program is ending with an error, then it crashes. Suppose I don't want it to, there may be a scenario where I cannot help, but the program cannot run. Say for instance, suppose I take two integers and AB, I scan them from the user and I return A divided by B, A by B. That's what I'll return. Now, in almost all cases, this will work. There is one case in which this will not work. When B is 0, because division by 0 is undefined. So even in computer, division by 0 is undefined. It will crash. It will say it's an error or it will crash. But this error cannot be found when you're compiling because the user still didn't give the input. Technically, syntactically, the program is correct. You're defining two variables, you're scanning them, and you're saying return A by B. But what is the value of A and B? I will know only after running it, only after taking the values from the user, right? So, but I need to imagine the possible scenarios in which this can fail. Okay, so what I will say, if B is 0, then return 1, which means the division is unsuccessful. Okay, else you just divide and return the value. Okay, so return 1 will tell me something wrong has happened. Maybe in this example, B may be 0. So the system will stop going to the next command. So ls has ended with an error. So don't go to the second command. Okay, so particularly the return values are useful when your program is part of a larger pipeline. Your program's input, your program's output becomes an input to the next program. In that case, you need to exit gracefully. You should not crash. Okay, so these are in almost every programming language, you will have these kind of things. They are called exception handling. It's called exception handling. In Java, you will have, in Python, you will have, but in C, there is no direct exception handling. You need to write the if-else statements. Okay, you will learn that later when you do other courses. So in this case, it doesn't matter when since during this course, we will deal with mostly standalone programs. We will not be dealing with this piping, this program's output going to some other program's input. We will not worry about that. And when you are writing standalone program, it doesn't matter whether you put the return statement or not. It doesn't matter whether you write return 0 or return 1. It doesn't matter. Even if you don't write return statement, if the program ends successfully, the system will automatically return 0 to the operating system. So you need not worry about that. But it's a good habit to write return 0 because in future, your program may become part of a larger pipeline. Okay, then you may not remember this. So if you make a habit from now, that will be good. That's the only thing. Okay, so technically, it doesn't matter right now for standalone programs. Okay, so let's not spend more time on that. And input statements, output statements, pure expressions, and assignment statements are all called expression statements, and they always return a value. No other kinds of statements do. This we just discussed. All right. So these are the things which I wanted to discuss in the last lecture. Okay, so let's move on to today's lecture. Okay, so far we discussed all the high level aspects of C. we discussed data types, different data types in C. We discussed different types of statements in C. We also discussed two kinds of operators, arithmetic and bitwise operators. Okay. So from now, whatever we'll be discussing will be now slightly more specific things related to the programming language, as well as some concepts we'll be discussing. So if you remember, how many kinds of operators are there in C? 7? 6. What are they? Arithmetic operators, bitwise operators, relational operators, logical operators, assignment operators, and miscellaneous operators. Okay, so out of these we discussed assignment operators and bitwise operators. Today we will discuss relational and logical operators, and the remaining two, assignment and miscellaneous operators, will be discussed in tutorials and labs. All right. Okay. So before we look at the operators, again we need to have a look at expressions. So don't worry about my writing. While uploading, I will refine it and upload. So expressions have a value, and an expression can be part of a statement. For example, this we saw earlier, like if I say x equal to 2 plus 3, here this is the expression and its value is 5. And this is part of this statement. This is a statement and its value is also 5. Right? So an expression can be part of a statement or a statement by itself. So that is, I can just write 2 plus 3 and leave it there in the program. That will also be a statement. All right. So this is a statement by itself and its value is 5. Okay. So all such statements are called expression statements, and their value is the value of the expression constituting them. Okay, so let's look at some examples. So let's consider an expression and its value. So in all these cases, assume x equal to 2 and y equal to 3 for all the below expressions. Okay. Now suppose if I just write 2, number 2, what is its value? 2. If I write 3, what is its value? 3. If I write x, we are assuming x is 2, y is 3. So what is the value of x? 2. What is the value of y? 3. So these are called numerical expressions. All right. Now we can combine them. We can perform some operations on them. We can use some operators and perform operations on them, right? So simple operations, which we all know, arithmetic operations, right? So What is the value of x plus y? 5. What is the value of x minus y? Minus 1. X into y? 6. X divided by y? Is integer division covered in the lab? We will get? Yeah. So what is the difference between integer division and real division? If both the operands are integers, then only the quotient will be the result. The fractional part is ignored. 2 by 3 is 0.666 something. But since 2 and 3 are integers, 2 by 3 is only 0. If you want the entire value 0.66 or if you want to truncate it to some portion, whatever it is, you should use float, or in this case we are not using variable. Okay, so either you directly use a float number, like you should write 2.0 by 3 or 2 by 3.0 or 2.0 by 3.0. One of them needs to be a float. Okay, or you convert one of them to float before you divide. Like say I can write it as 2.0 by 3, or I can write it as 2 by 3.0, or I can write it as 2.0 by 3.0, or I can write it like this: float 2 by 3 or 2 by float 3. At least one of them should be a real number, float or double, it doesn't matter. But if both are integers, then the division will take only the quotient value. The result will only be the quotient, not the fractional part. Okay, so that is the thing. So here we are taking 2 by 3, x and y are integers. So here the result will be, what is the quotient? 0. Okay, and x mod y, yeah, x mod y is 2. What is the remainder when you divide 2 with 3? 2. And minus x is minus 2. Okay, so these, what did we use here? Arithmetic operators. And how many arithmetic operators did we use? 6. Addition, subtraction, multiplication, division, modulus, and unary negation. So this is binary minus, and this is unary minus. Okay, and what do we get from arithmetic operators? We get arithmetic expressions. So these are arithmetic expressions, right? Now bitwise is similar, so I will not get into that because we don't have much time. We will move on to other operators, relational and logical. So suppose I say x greater than y. Any guesses what is the value of this expression? X greater than y means we are asking if 2 is greater than 3. So what will be the output? False. Okay. So false and true, these are Boolean values. Fine. Normally in other programming languages, you have a special data type called bool, like we have int, char, float, etc. You have a type called bool. So you can directly use true and false as values. Okay. In C, we don't have them directly. We can include them if we include a library called stdbool.h. Okay, but by default they are not there. So we'll not worry about including stdbool.h. We will just assume they are not there. These data types are not there, true and false. In place, we have just zeros and ones. True means 1, false means 0. Okay, so this is false. So its value is 0. Okay. What about x less than y? It is true. So its value is 1. X greater than or equal to y. Is this true or false? False. So 0. X less than or equal to y. True. So 1. And x equal to y. false, 0, x not equal to y, it's true. 2 is not equal to 3, that is true. So output is 1. Okay. So this double equal to, I mentioned already, but I'm mentioning again, the mathematical equal to which you use in mathematics is represented in programming using double equal to. Okay. If you are using single equal to, that is not the mathematical equal to. That is assignment. Okay. So you are assigning the value of RHS to the variable in LHS. Okay. So when we say x equal to y double equal to, it is comparison. All right. But when you say x equal to y single equal to, it is the same as, you can write it like this. You are assigning the value in y to x. Okay. So this is assignment operator. We didn't cover assignment operators. They will be covered in labs and tutorials. Basic assignment. This much you already know. You are assigning value of RHS to LHS. Okay. So usually students make mistakes in this. Instead of single equal to, they put double equal to and vice versa. Don't make that mistake. All right. Okay. So these operators are relational operators. Or they are also called Boolean operators. Why? Because why are they called Boolean operators? Because they return true or false. That's all, 0 or 1. Okay. So what all operators we saw? How many relational operators? 6. Greater than, less than, greater than or equal to. In the program, when you're writing greater than or equal to, you can't write, there is no symbol like this. So you have to put greater than symbol and then equal to symbol. Okay. Greater than or equal to, less than or equal to, and not equal to. And what do we get from relational operators? I mean, we get relational expressions or Boolean expressions. Okay. So these are called Boolean expressions because they refer to those expressions which return a true false value, that is 1 or 0. Okay. All right. Now let's move on to the next kind of operators. So suppose I take the previous expressions, Boolean expressions, say x greater than y is one Boolean expression, and say x not equal to y is another Boolean expression. Now I combine them using another operator, that is AND, logical AND. You see the difference between bitwise AND and logical AND? In bitwise AND there is only 1 ampersand. In logical AND there are 2 ampersands. Again, you may make mistakes in this. Keep in mind how many ampersands or how many bars you are using. In OR also there will be a confusion. Okay. So x greater than y and x not equal to y. This is a relational expression. This is a relational expression. This is a logical operator. Okay. Now what is the value of this? 0. What is the value of this? 1. And this is AND operator. So 0 and 1 is 0. Okay. So this is false. False and true is false. So the value is false or 0. Okay. Now let's take another operator, x greater than y or x not equal to y. This is 0. This is 1. This is OR operator. 0 or 1 is 1 or true. Okay. Then not of x greater than y. Okay, so what is this? This is 0, this is not, let me write it here, this is not, so not of 0 is 1. Okay, so this is true, so the value is 1. Fine. These are called logical operators. And how many operators are there? 3. And, or, not. All other things, NAND, NOR, those, see, bitwise logical AND is different from, sorry, bitwise AND is different from logical AND. Bitwise NAND is different from logical NAND. So NAND, NOR, you can get by combining these 3. Fine. So in bitwise, you are breaking a number into bits and performing the operation at bit level. In logical AND OR, you are taking the number as such and then performing at the number level. You will see, we will see the examples just in a while. Okay. So basically, it's not just numbers. Logical AND OR, they're treating with, they're dealing with true false values. True and true, true and false. They are like propositional logic, P and Q, P or Q, P implies Q, those kind of things, right? So there you are dealing with true false values. You're not dealing with binary digits or binary numbers. Same thing here. Here logical operators are assuming the inputs are true false values, either 0 or 1. Okay, so we will see that. So using logical operators, you get logical expressions. All right. So now if you see, initially we started with plain numerical expressions, either constants or variables. Fine. Then arithmetic operators or arithmetic expressions, they take numbers and they give numbers. Like 2 plus 3, both are numbers, and the output is 5, which is also a number. Okay. So arithmetic expressions take numbers and give numbers. Input is numbers, output is also numbers. And logical operators, they take zeros and ones, true false values, and the output is also either true or false. Okay, so input is 0 or 1 and the output is also 0 or 1. Relational operators, what they do, they take numbers as input. Is 2 greater than 3, 2 not equal to 3. They take numbers as input and they return true false values as output. Okay, so arithmetic operators deal entirely with numbers. Input and output both are numbers. Logical operators deal entirely with true false values. Input and output both are true false values. Relational operators, input is numbers, output is true false values. Okay, so the sequence is somewhat like this. You give numbers as input to arithmetic operators and they in turn return numbers. Okay, now you give these numbers as input to relational operators and they return true false, that is 1 or 0. Okay, or let me put it like this, 1 or 0 representing true or false, and this 1 or 0 becomes an input to logical operators. And what do they return? Same thing, 1 or 0 representing true or false. Okay, so I hope you saw the pattern. We are building larger and larger expressions. We started with numbers, then we built arithmetic expressions whose output is also numbers, and then we took the numbers. See, numbers always need not go through arithmetic expression to go into a relational expression. You can directly give numbers in relational expression also. Any order is fine. The input is numbers, output is numbers in arithmetic, but input is numbers and output is 0, 1 in relational. That's all. Now you started with numbers and got 0 or 1 as output in the relational expression. Now you took relational expressions and made them a part of a logical expression. Okay, fine. Now it is not necessary that you need to stop here. Okay, you can build larger and larger expressions, and a logical expression can become a part of an arithmetic expression or a relational expression, or a relational expression can become a part of an arithmetic expression, and so on. So you can play with them any way you want. Okay, because every expression has a value. Finally, it is the value which is becoming part of another expression. Okay, so how do you build larger expressions? Now, if you look at each of these operators, you will find two kinds of operators: binary operator and unary operator. There are some operators which take two values. There are some operators which take only one value, like plus, minus, multiplication. These are binary operators because they need two arguments, two operands. Unary negation, it needs only one operand. Similarly, logical and logical OR, they need two operands. This and that, true and false, or true and true, something like that. They need two operands. Only not of an expression, that is a unary negation, that is a logical negation, that needs only one operand. Okay. Similarly, bitwise not, that is a unary negation, that also requires only one operand. So again, don't confuse between logical negation and bitwise negation. In logical negation, true is becoming false, false is becoming true. Okay. But in bitwise negation, whatever number you are taking, you are flipping the bits. So it's like complement or one's complement. Okay. So be clear which operator you want to use. If you use exclamation mark, it is logical negation. It is not bitwise negation. Bitwise negation is what? Tilde. This symbol. This is bitwise negation. Okay. This will not convert true to false, false. This will convert. If there is only 0, it will convert to 1. If there is only 1, it will convert to 0. But that is basically flipping the bit. But if you are giving, say, negation of 4, it will take 4 in binary and then say it will convert to, it will flip it, and negation of 4 is 3. So here the answer will be 3. But if I say exclamation of 4, here 4 is a non-zero number. Any non-zero number is considered as true value. So negation of a true value is false, which means 0. So logical negation of 4 will give you 0, whereas bitwise negation of 4 will give you 3. So both are different. Fine. We will see that in detail in a while. So basically, you can build larger and larger expressions by using either a binary operator or a unary operator. So if you have a binary operator, you need two expressions, right? Say expression 1 and expression 2. And is there any restriction on this binary operator and the expression? If my binary operator is an arithmetic operator, should these expressions be only numbers? No. These expressions can be anything. They can be logical expression, they can be relational expression, they can be anything. Because finally, all those expressions will also have a number as value. 0, 1 is also a number. Logical expression will return 0 or 1, that is also a number. Relational expression will return 0 or 1, that is also a number. Arithmetic expression will return some number, either 0, 1 or some number, that is also a number. So any expression can become part of a binary operator. So this binary operator can be arithmetic or relational or logical, anything. So any expression 1 and expression 2 can be any expressions, and this operator can be any binary operator. There is no restriction. You can combine them any which way you want. That's all. And you will get a new larger expression. Okay. If you are using a unary operator, say minus, unary negation, or not, logical negation, or bitwise negation, whatever it is, you can again, so that can become an expression. Okay. So unary operator, and you have an expression. Okay. So this operator can be any unary operator, and this expression can be any expression. So unary operator need not be applied only to a number or something. You can negate an entire relational expression. You can perform logical negation on a relational expression or an arithmetic expression, anything. You can match them any way you want. Okay, you can combine them any way you want. This is another way of creating a new larger expression. Okay, this can become part of a binary expression, or a binary expression can become part of a unary expression, and so on. Okay, so these are different ways in which you can build a larger expression. Now let's look at an example. Okay, so let's say take 4 logical and 5. You see, normally logical operator, this is logical and, right? Normally logical operator takes only relational expressions as input, but that's not necessarily the case. Normally that's what the case is, but we can combine them any way we want. Technically anything can be an input. I can directly give a number also as input. Okay, but logical operator expects true and false values so that it can perform true and true, true or false, those kind of operations. So in this case, how do I map these numbers to true false values? I just mentioned. Yeah, no, it's not. It has nothing to do with positive and negative numbers. It has something to do with zero and non-zero numbers. Any non-zero number, whether it's positive or negative, is considered to be true. Only 0 is considered to be false. Okay, so here 4 is considered to be true, 5 is considered to be true, which means 4 is considered to be 1, 5 is considered to be 1, 1 and 1 is 1. So the value of this expression will be 1. Okay, now let's build a larger expression. 4 and 5 is equal to 7. This is another expression. Okay, now we got the value of this expression already. What is the value? 1. What is the value of this expression? Just 7. What is the value of this expression? 7. Is 1 equal to 7? No. So it is false. So it is 0. Okay, so the value of this entire expression is 0. Now we can use this expression in a larger expression. Okay, so let me copy it. So this expression is greater than 5, not equal to 5. We got the value of this expression. What is it? 0. What is the value of this expression? 5 not equal to 5. What is the value of this expression? Is it true or false? False. False means 0. Is 0 greater than 0? No. Which means false. False means 0. So the value of this entire expression is 0. So let me copy it. Now this becomes part of a larger expression, say plus 20. What is the value of this expression? 0. What is the value of this expression? This expression 20. 0 plus 20, 20. So the output of this entire expression, the value of this entire expression is 20. Okay, so this is how you can combine expressions in any way you want. All right, let me give you an example and you tell me what is the value of that expression. So suppose I say 5 and 3 or 7 not equal to 7 greater than 12. So what should we do? First find the value of this. What is the value of this? 1. This is like 5 is 1, 3 is 1. True, true. So output is true. That is 1. 1 or 7 is 1. 1 not equal to 7 is 1. 1 is not equal to 7. That is true. So 1. 1 greater than 12? False. So the output is 0. So the value of this expression will be 0. Okay. One more. x equal to y equal to 2 not equal to 5. What is the value of this entire expression? Yeah, 1. Why? First of all, you should, so assignment operator, you should go from right to left. First, you should calculate this one. Is 2 equal to 5? No, it is true. So this one will be assigned to y. And then this one will be assigned to x. This one will be the value of the entire statement. Okay, so the entire expression has value of the leftmost LHS. That's all. What about this one? 4 plus printf hello. Yes? 9. Why? What is the value of this? 5. Good. 4 plus 5 is 9. Suppose if I change this hello to hello backslash n, 10 or 11? 10, because this backslash n together is one character. Okay, so it will be 10. Okay, so output is, or the value is not for hello. Output is hello. Value is 9 or 10 depending on new line or no new line. Okay. All right. So I just want to mention one thing. Okay, I'll write it in detail while uploading. So the point is 0 and 1 can be treated as regular numbers and also as representing false and true values respectively. So they can be treated as regular numbers or they can be treated as representing false and true values. So they can be used in any expression. Fine. Logical expression they can be used, arithmetic expression they can be used, relational expression they can be used. Okay. Similarly, any number we take like 4, 5, 10, minus 100, minus 20, negative number, positive number, those numbers also can be used as a regular number as well as representing true false values. Any non-zero number, including negative numbers, represents true, while 0 represents false. So negative number does not represent false. Negative number, as long as it is not 0, that is also representing true value. Okay. So you can consider them as numbers or you can consider them as true false values. So they can also be used in any expression, arithmetic or relational or logical. So all numbers 0, 1 or any non-zero number can be used in any expression. Okay. That's the idea. Fine. So you can combine, you can play with them any way you want. You can combine any operator with any expression. You can use any number, any variable, any way, any which way you want, you can combine them to build larger and larger expressions. Okay. So we covered arithmetic, bitwise, relational, logical, assignment operators and miscellaneous operators will be covered in the in labs and tutorials. And second thing, your exam will most probably be not next Wednesday, but next Wednesday, the Wednesday after that. Most probably in the afternoon. Okay. And before that, you will have a sort of a take-home assignment. Like you will be given 5-6 days to submit your solutions online, and that will be conducted by Programming Club. So Programming Club conducts contests, right? So there will be a contest exclusively for first years. There will be problems given to you. You need to solve those problems and upload the solutions online. Okay, this is compulsory. This is part of your lab component. Lab exam is separate. Okay, so before lab exam, this contest will be conducted to give you an idea. Okay.